The explosive death of stars led to the formation of the first galaxies, but it also sprinkled the universe with heavy elements, including those needed for life itself. Welcome back to the second episode of our journey through the universe. In the last episode, we witnessed the Big Bang and the birth of the very first light. But what happened next would change the universe forever: the creation of stars and galaxies. As the young universe expanded and cooled, gravity began to pull massive clouds of hydrogen and helium gas together. When the pressure and temperature grew high enough, something extraordinary happened. The first stars were born. These stars lit up the darkness for the very first time, ending the age of cosmic night. Inside their blazing cores, nuclear fusion created heavier elements: carbon, oxygen, nitrogen, the very ingredients necessary for life. But stars are not eternal. The most massive ones lived fast and died young, exploding in colossal supernovae. In those final moments, they forged even heavier elements like iron and gold, scattering them across space. These explosions seeded the universe with the materials that would one day form new stars, planets, and even living beings. Over billions of years, stars grouped together, bound by gravity, forming galaxies. Each galaxy became a vast cosmic city, home to billions of stars. Our own home, the Milky Way, is just one of more than 2 trillion galaxies in the observable universe, each one a swirling ocean of light stretching across unimaginable distances. But let's rewind time and see how this all began. Immediately after the Big Bang, the universe was a hot, dense soup of elementary particles. As the universe expanded and cooled, protons and neutrons combined to form atomic nuclei, which then captured electrons to create the first atoms, mostly hydrogen, with some helium and trace amounts of lithium. This primordial mixture is known as a primordial soup. It was a time when matter dominated over antimatter. For every matter particle, there was an antimatter counterpart that would annihilate upon contact, releasing energy. This symmetry between matter and antimatter was puzzling because if the amounts were equal, they would have completely annihilated, leaving behind only light and energy. But observations of the present-day universe indicate that there is far more matter than antimatter. Scientists believe that a slight asymmetry existed in the early universe, allowing a small excess of matter to survive the initial annihilations. This asymmetry, though tiny, was crucial as it provided the matter needed to form the first stars and galaxies. As the universe continued to expand and cool, the hydrogen and helium atoms began to clump together under the influence of gravity. These early collections of atoms were not yet stars or galaxies, but rather the building blocks from which they would eventually form. They were immense, dark, cold clouds of gas floating in the blackness of space. Stars formed in these clouds as gravity caused them to collapse. As the clouds collapsed, they heated up dramatically. When the core reached around 10 million Kelvin, nuclear fusion ignited, turning hydrogen into helium and releasing tremendous amounts of energy. This energy outward pressure balanced the inward pull of gravity, creating a stable star. The first stars were massive, hot, blue giants, radically different from our Sun. Their formation marked the end of the cosmic night and the beginning of an era when the universe was filled with light. Inside these stars, fusion reactions produced not only helium, but also heavier elements like carbon, oxygen, and nitrogen, the very elements essential for life as we know it. The creation of these elements enriched the universe, laying the foundation for the complex chemistry that would occur in later generations of stars and planets. Stars, however, are not immortal. Their lifespans depend on their mass. More massive stars burn through their fuel faster and have shorter lives. Our Sun, a relatively small star, is expected to live for trillions of years. But the massive blue giants lived fast and died young, often in spectacular fashion. When a massive star exhausts its nuclear fuel, the outward pressure that had balanced gravity collapses and the star implodes. This implosion can release a massive amount of energy in a supernova explosion. Supernovae are among the most energetic events in the universe, outshining galaxies and serving as cosmic furnaces to forge even heavier elements. Iron is the end product of nuclear fusion in a star. Further fusion requires more energy than these stars can produce, so elements heavier than iron are created in supernovae. During a supernova, the core of the star is compressed to extreme densities, forcing electrons to combine and releasing protons and neutrons. These free neutrons can then capture protons, creating elements heavier than iron. Gold, one of the most sought-after elements on Earth, is one such byproduct of supernovae. These elements, released in supernovae, become part of the interstellar medium, the very material from which new stars and planets will form. This recycling of material is crucial to understand how the universe evolved over billions of years. After many such cycles, the universe became rich in heavier elements, enriching the interstellar medium and setting the stage for the formation of more complex objects like planets and later life itself. Now let's focus on the birth of galaxies. Initially, the distribution of matter in the early universe was not uniform. There were slight variations in density due to quantum fluctuations during the Big Bang. These small variations were amplified by gravity as matter clumped together. Over time, the densest regions became the seeds of galaxies. As more matter accumulated under the influence of gravity, these seeds grew into massive stars and dense clumps of gas and dust. The process of star formation within these clumps further enhanced their gravitational pull, drawing in more matter and accelerating the growth of the galaxies. This positive feedback loop led to the runaway growth of galaxies. They became gigantic assemblies of stars, gas, dust, and dark matter, all held together by their mutual gravitational attraction. The most massive stars migrated to the centers of these galaxies, forming the bright, brilliant bulges we observe today. Around these bulges, flattened disks of stars emerged, along with vast halos of spherical star clusters. In the grand scheme of the universe, galaxies are relatively small. Most are separated by vast distances, each occupying its own region of space. Our home galaxy, the Milky Way, is a barred spiral galaxy. Its name comes from the Latin word for milky, aptly describing its appearance from Earth as a band of light stretching across the sky. The Milky Way contains hundreds of billions of stars and is part of a local group of galaxies. However, it is just one of billions upon billions of galaxies in the observable universe, each a majestic island of stars in the cosmic sea. And now for a quick recap. We started with a bang, the Big Bang, and watched as the universe rapidly expanded and cooled. Elementary particles formed, then combined to create the first atoms. These atoms, mostly hydrogen and helium, were drawn together by gravity, forming the first stars. Inside these stars, nuclear fusion gave rise to heavier elements. Massive stars ended their lives in supernova explosions, scattering even heavier elements like gold into space. These elements were the building blocks for future stars and planets. Over billions of years, stars grouped together under the influence of gravity, forming the first galaxies, the grand architects of the cosmos. As the universe continued to expand and evolve, the stage was set for the birth of planets, moons, asteroids, comets, and perhaps most importantly, life itself. In the next episode, we'll delve into the birth of our solar system and explore how the Sun and its planets came to be. Join us as we continue our journey through the wonders of the universe. Thank you for watching. If you enjoyed this video, don't forget to hit the like button, subscribe to our channel, and tap the bell icon to enable all notifications so that you never miss any of our videos. You can also watch the first episode of this series right here. Thanks for joining us, and we'll see you next time.